Welcome guys, welcome to the course of TCP/IP. Today we are going to discuss about the concept of IP version 26 in which the how auto configuration is going to be made available for the host. That concept we are going to discuss. In the next video, we are going to demonstrate this theoretical portion of the auto configuration in IP version 6. So let's start with the theoretical portion. So very first question, that what do you mean by auto configuration? Here, one of the interesting feature of IP version 6 addressing is what the auto configuration of the host. So auto configuration of the host is what the host is getting the IP address version 6 for the communication. That is what the auto configuration. Which, as we discussed in IP version 4, the host and the router are configured manually by the network manager. However, the DHCP, that is Dynamic Host Configuration Protocol, can also be used to allocate IP version 4 addresses to the host that join the network. So in the earlier version, uh, uh, network administrator can manually assign the IP address, or maybe with the help of DHCP protocol, the provision was available in the IP version 4. But here, automatically is going to be done. But in IP version 6, DHCP protocol can still be used to allocate it IP version 6 address to the host, but the host can also configure itself. So the auto configuration capability of IP version 6 saved network administrator lot of works. So here, if the addresses are going to be automatically assigned, so network admin did not to bother the things how it can manage all the hosts which are connected to that particular network. So it is going to be automatic. It has been designed to ensure that the manual configuration host before connecting them to the network is not required. So manual configuration is not required, guys, over here. So even large site with the multiple networks and the router should not need DHCP server to configure host. And the auto configuration feature of the IP version 6 will be a key feature of the protocol when all sort of devices such as TV, refrigerator, DVD, and mobile phones use IP address. So any kind of IoT devices that wanted to get an IP address from the server, that automatically get the IP address with the auto configuration, because nowadays the size and the numbers of the devices are very more. So manually it is very hectic task to assign the IP address. So automatically it's going to be assigned. We don't want to depend upon the DHCP server to use the our home devices. So this is what the gist of this slide is. Slide is what. So here in the IP version 6, the addresses, the IP addresses are going to be automatically assigned to every host which are connected to that particular server. Okay. Now here in this slide, I'm showing you the topology for the creation of the auto configuration, where the router is there, the two switches are there, and there are three computers. So if I go with this part, guys, so this is what the another network, and this is what the another network. What we are going to demonstrate in the second video, that this computer will get the link local address. This computer also will have the link local address, and this router interfaces also will set the link local address. And in this particular portion, we are going to make enable that what the local link addresses. But if this computer want to communicate with this computer, that time global unicast routing is going to be required. So how this scenario is going to be work, that will demonstrate in second video. Okay. Now here there are different states of the IP version 6 addresses, guys. Actually there are three states. The very first state is what the tentative address. This is an address that host 8 not been assigned. It has the state prior to assignment when the uniqueness is being verified. So the tentative address is what the tentative address has not been assigned to that particular host. So once that uniqueness test is passed, that time after that is going to be assigned. But here this is what the prior state to that uniqueness test. Okay, this is what the temporary address or tentative address. Then preferred address. This is what the address that has been assigned to the interface and that can be used without any restriction. So this is what the preferred address. Then deprecated address. The deprecated address might be one whose lifetime is about to expire. It can still be used to continue communication with that would disturb the services if the address change. It is no longer used as a source address for newly established connection. So this what deprecated address is what deprecated address might be used one whose lifetime is about to expire. So there are three states are available: tentative, preferred, and deprecated. On the basis of these three particular states, the IP address are going to be assigned at different states. Okay. Then there are two types of auto configuration. The very first is what the stateful auto configuration, and second would be what the stateless auto configuration. So what about the stateful? The stateful auto configuration is the IP version 6 equivalent to the DHCP version 4. So whatever the version DHCP protocol available in IP version 4, which is equivalent to this particular stateful addresses. The new protocol, that is DHCP version 6, as like the IDSCP version 4, is used to pass out the addressing and service information in the same way that the DHCP is used in IP version 4. So the meaning of this sentence is what the mechanism available with the DHCP is as good as available in the DHCP version 6 is called as what the stateful auto configuration. And this is called a stateful because the DHCP server and the client must both maintain the state information to keep the addresses from conflicting, to handle the lease and new renewal addresses over time. So here what we have discussed three states earlier: tentative, deprecated. Okay, and that kind of states are very important over here, so that the conflicting and the least conflicting will never be happen, and the renewal can be possible. So ultimately what our purpose is, what to assign an IP address which is unique. So that uniqueness test is must. Okay, so this is what the stateful auto configuration. But the second is what the stateless auto configuration. In the other type of auto configuration in IP version 6 is what the stateless auto configuration. With the stateless auto configuration, the host gain an IP address via interface automatically. So this is what the new feature. It get the IP address via interface automatically. Leasing an IP address and does not require establish of a server to delve out an address space. So here that host cannot required to work for that one, that is going to be assigned automatically. The stateless auto configuration allows host to propose an IP address which will probably be unique based on the network prefix, but here only network prefix, let's say A, network prefix, let's say B. In that particular network, that address will be unique, and this Ethernet MAC address, and propose it use on the network. So this is what the uniqueness, because no server has the approve no has to approve the use of addresses or pass it on. The stateless configuration is simpler, and this is what the default mode of the operation for the most IP version 6 system, including the server. So in this IP version 6, what we get the IP address, we get the IP address via stateless auto configuration, where the computers interfaces are getting the IP addresses automatically. With the only we have to, what we have to set the global unicast address at the router end. So automatically the other host will get the IP address. Then, so here there is a one concept, that is a link local address. Okay, so what do you mean by link local address? The link local address is an IP version 6 unicast address that can be automatically configured on any interface using the link local prefix, and prefix is what? FE80 colon slash 10. Okay, and the interface identifier is modified, that is EUI 1664 format is going to be used. So how this 64 format is going to be used? We have a process to calculate this 64 EUI address. We are going to demonstrate in the next slide. The link local address can also be manually configured with the in the FE80 colon colon slash 10 format using the IP version 6 address link local command. So this can also be manually configured, but moreover, it is going to be automatically available with the help of the EUI and the MAC address technologies. These addresses refer only to the particular physical link and are used for addressing on the single link for the purpose such as automatic address configuration and the neighborhood discovery protocol, that is ND protocol. The link local address are not necessarily bound to the MAC address that is configured in the EUI 64 format. Then the link local address can be used to reach a neighboring node attached to the same link. The node do not need global unique address to communicate. Then the router will not forward the datagram using the link local address, and also the IP version 6 router must not forward the packets that have the link local address or destination address to the other links. The meaning of this slide is what? Let's see, if I have a computer over here, if I have, let's say, switch over here, and here let's say I have a router. Okay, if I want to communicate from this to this to this, it is possible because I am local to this. I am local to this. If let's say if I have another computer over this on the switch, So I can ping to this network, and I can ping to this computer, and this can ping to this computer. But let's say at the left side, if I have another network and there is one computer, so I cannot ping directly from this to this if I have set the link local address, because what we have enabled only link local unicast. So for that purpose, what we have to do, we have to set the global unicast addressing over here. Then only it is possible to communicate over here. So link local address is assigned, and link local address can be same on the router interfaces. It can be possible, but it is difficult. It is different at the every node, which is automatically that going to be allocated for that particular host. So this part we are going to demonstrate in next video lecture. So please do watch that video. Then we'll see that how this EUI, that is extended unique identifier, is going to be calculated and what that purpose of it. The EUI is what the extended unique identifier is, a method we can use to automatically configure IP origin 6 host addresses. And in an IP origin 6 devices will use the MAC address of its interface to generate a unique 64-bit interface ID. So for generating the EUI ID, what we have to consider, we have to consider the MAC address. However, the MAC address is of only 48-bit and the interface ID is over 64-bit. So there is a difference between the 64 and 48. So what we are going to do is what the bits are missing. So what we will do, the missing bits. So to bridge these missing bits in between the MAC address and the interface ID, we have to use the methodology, and that methodology is called the EUI methodology. Okay, while we could manually configure the host bit for the router interface, the more efficient approach might be to automatically calculate those host bit using the 64-bit extended unique identifier known as EUI64. For example, let's say if we have the router interface on the IP origin 6 network, like 2000:1:64, we could enter the command, like let's say in the IPv6 address 2000:1:64 EUI64. So this is what the command which we are going to preferred in this demonstration part, where this is what the CIDR that is the available with that. This is what the IP address, okay, and this is what the extension to the TUI. And this command tells the interface to use the 2000:1:, as a network portion of the IP origin 6 address, and to automatically calculate the 64-bit host portion of the IP origin 6 address. So let's take how to calculate this EUI. There is a standard process available, guys, and that standard process is what on the basis of that MAC address. So let's take an example of this EUI calculation. Let's consider the scenario where there is a router 1 who's having has a MAC address of, let's say, 0015 2BE4.9B60 on its fast Ethernet 0/0, okay, interface. Then calculate the corresponding EUI64 address based on this MAC address. So what we have given? We have given this MAC address of that router on the fast Ethernet. Okay, on the basis of that, we have to calculate the EUI64 ID. Step number 1, what we have to do? We have to split the MAC address in the middle. So what we have, 1, 2, 3, each of 2 byte 16 bits available in each block. So here we are separating this address into 2 blocks. So here let's say 1 block, and this is what the second block. So we have splitted the middle bit, okay, to 1 byte over here, 1 byte over here. Then step number 2, insert the standard bit pattern, that is FFFE, in the middle. So, okay, so we have inserted this bit pattern block in this middle. Okay, then change the format to use the colon delimiter. So what we have earlier, we have only a dot over here, okay, dot over here. So what we have to do, we have to change this notation into the colon. So my address will be 0015, then 2BFF, then FEE4 9B60. So what we have did over here, we have inserted the colon notation. Okay, then step number 4, convert the first 8 bit to the binary. So what the bit we have, the first 8 bit, the 4 plus 4, 8 bit we have to convert. So 0 and 0, what we have, 0 and 0. So this is going to be converted into the binary. So all zeros available over here. Then what to do? Step number 5, flip the seventh bit. Whatever the bit over here, flip the seventh bit. If this bit is, let's say, 0, it will be 1. It will be, if it is 1, it will be 0. So here in this case, it is 0. So we have flipped this bit into the 1. Okay. And then step number 6, convert this first 8-bit block into the hexadecimal format. So what we are going to do, we are going to convert these bits into hexadecimal. So all consecutive 4 will be 0, and this next 0010 will be what? 02, which L2B and what the EUI64 address of 0215 2BFF FEE4 and 9B60. So this is what the 6 steps are available to calculate EUI, and this is very important because only we have interface IDs of the 64-bit, and what we have the MAC address is only of 48-bit, guys. So bridge that gap. What we have the EUI extension is available, and there are simple steps are available, and we'll demonstrate these things with the that particular scenario also. So please do watch that also. Do watch that video also. I hope this is okay. Now, there are the standard steps are available of the auto configuration. So that steps is what very important, and this is what the gist of all this video lecture. This stateless auto configuration is going to be done via the ND protocol, that is the neighbor discovery protocol. The host locates an IP version 6 router on the local link and requests a site prefix. So let's take the process and the steps involved in the stateless auto configuration in IP version 6. So very first, it generate a link local address. It generate a link local address. So on this computer, what we have to do, link local address we have to generate, and this is going to be generated automatically. The device generate the link local address which has 10 bits followed by 64 zeros and followed by 54 zeros and followed by 64-bit interface ID, and this is what the tentative address. So to generate the link local address, how to generate? It is going to be generated on the basis of that what the EUI technology. Okay, so that we have discussed earlier. Then once this link local address generate, basically because this link local address is what tentative, because this is it not been assigned to any host, because it has to pass the uniqueness test. Okay, so for that purpose, what we have the second step, and that second step is what the uniqueness of the link local address. In this step, the node tests to make sure that the link local address that is generated is not already in use on the local network. So we have to check the uniqueness. Is it already available in the local network? Okay, the node send a neighbor solicitation message by using the ND protocol. In response, the local network listen for the neighbor advertisement message, which indicate that another device is already using the link local address. So it is going to be done via this ND protocol. This is going to be done via ND protocol, which specifically neighbor solicitation message. Okay, if so, if that address is already available, if so, if that address is not already available, then what to do? If so, either a new link local address must be generated, or auto configuration fails and another method must be used. If the address is already available, so this method is going to be fail. Okay, so link local address must be generated or the auto configuration to be failed. And then if it passed the that uniqueness test, if that passed it passed the uniqueness test, then what to do? What we have to do? We have to go to the third step, and that is what assign a link local address. If the device passes the uniqueness test, the device assign the link local address to its IP interface. The link local address can be used for the communication on the local network, but not over the internet. As I told you guys in the demo topology part, this link local address is only reachable to that network only. We cannot ping the another network any computer without any global unicast routing. So this is what the local to that particular network. So this is what the main purpose of this link local address. After getting that link local address, what we have to do? We have to switch to the step number 4. And the step number 4 is what? To contact the router. The node tries to contact the local router for the more information about continuing the configuration, about the about the continuing the configuration. The contact is preferred performed either by listening for the router advertisement message or sent periodically by the routers, or by sending a specific router solicitation message to ask the router for information about what to do next. So in this contacting to the router, this will be done automatically, let's say done by the router itself, or we can send the router solicitation message. And what the solicitation? We are sending the request. Solicitation, what sending the request on the behalf of, let's say, our requirement. Okay, these both the things can be possible to get an information, configuration information from the router. Then we have to go to the step number 5. Then provide the direction to the node. The router provide the direction to the node about how to proceed with auto configuration. Alternatively, the root tells the host how to determine the global internet address. Okay, then the step number 6, configure the global address. The host configure itself with the global unique internet addresses. This address is generally formed for a network prefix provided to the host by the routers. So these are the 6 steps are available, guys, in order to get an IP address to that particular host. And these steps are moreover what we have discussed in theoretical portion, where what we have: generate a link local address, test that address. If fails, another matter. If okay, then assign the address, then contact to the router, then provide the direction to the node, then configure the global address. This is what the overall process of the auto configuration, where we require to calculate the EUI on the basis of the MAC address. But this will be more clear once we demonstrate this particular topology in the next video lecture, where we are going to create this topology where we assign, we get the IP link local address to this, link local address to this. We'll first ping from this to this, then this to this. Then we'll also try to ping to this particular interface, where another will set the link local address. Okay, but if you wanted to ping from this via this, this will not be assigned, this will not be allowed, because what we have to do, we have to set over here the global unicast address. Okay, because as I told you, link local address is only visible or only permittable to only this particular local address, local network. This is not going to be available over here, even only unless we have to set this particular global unicasting over here. So this topology we are going to demonstrate in the next video lecture. I hope, guys, this video is okay with you. Thank you so